Let me just refresh our memory. A context-free grammar is one in which is where the left side of each production is just a single non-terminal symbol. Is a single non-terminal. That's like one of the big letters, right? Big S, big T, that kind of thing. What about... Okay, so what we were talking about last time is how you can create a context-free grammar for a language. If I describe to you some set, say, give me a grammar for this. Now, sometimes it's not possible. Like this set, for example, doesn't seem all that complicated. A to the M, B to the N, C to the N. Actually, you cannot make that set using a context-free grammar. It's not really easy to see why that is, although we will talk about it eventually. I was talking about what? Sorry, my papers are all out of order here. Oh, that's why. Thanks. Okay. So at the end, last time we were talking about how to combine together sort of simple grammars into a more complicated grammar. So we talked about, first of all, concatenations of two grammars. To concatenate grammars. That is, I have a grammar which describes sort of the first half of the strings and another grammar which describes the second half of the strings. How do I put them together? You go like, you make it like this. S goes to S1, S2, and then S1 goes to whatever the grammar is for that part, and S2 goes for whatever the grammar is for that part. The idea is if you have already two grammars for two things, this is one way that you can combine those two grammars together to get the concatenation of the two languages. So, for example, if I wanted, say, the language A to the 2N, B to the M, A to the M, I look at this as a concatenation of two different parts. They are here and here. Now, when you want to isolate this into two separate parts, you need to take the B to the M, A to the M together because they share that M there, right? So you can't split that up apart from the other part. But then this A to the 2N at the beginning is all by itself, right? And the idea here is you make a grammar for each one separately, and you combine those two grammars together. So for the first part here, I'll call this one S1. And to get A to the 2N, you want to do something like this. S1 goes to A squared S1 or epsilon. This way you can generate A squared over and over again, which gets you A to the 2N. And then B to the M, A to the M, I'll use the S2 for this one. And remember, how do I make a grammar or a language like that with a grammar? You need to balance out the number of B's and A's. Or BS2A or epsilon. Great. You create B's and A's together, and the B should be in front and the A should be in the end in order to make that work. Excellent. So our final answer then, the overall grammar for this, let's call this language L. So a grammar for L is S goes to S1, S2, and then S1 goes to A squared S1 or epsilon, and S2 goes to BS2A or epsilon. There you go. So this is one way in which you can look at a complicated language and kind of break it up into simpler parts, right? That's the idea. And of course, if you can break it into three parts, then you go, S1, S2, S3, right? That's just like this. Any questions about that? This is one kind of way of breaking it up. We're going to talk about a couple others. So another one, actually just one other. This was all about concatenations, to concatenate grammars. What about a grammar for the union? A grammar for the union. How about this? The language which consists of a to the k, b to the k, union, I would say x such that x has an even number of a's. The union, right? Remember the union, of course, for sets means it's in the first one or it's in the second one. So we are going to have a similar strategy. I make a S1 for this one, goes to something, something, something. We'll talk about that. And then this one I'll call S2. Make a grammar for that one, all right? Anybody want to suggest how could we combine things together to get a grammar for the union? Now for the concatenation, remember, we wrote S goes to S1 followed immediately by S2. For the union, I want things which are either in S1 or S2.
Yeah. S1 bar S2.
Yeah, so to get the union, this is not just in this example, this is always how you do it. You start with S goes to S1 or S2, like that. And then you just fill in. S1 goes to whatever, S2 goes to whatever, right? So you can, I suppose, memorize this. I mean, it's not all that complicated, right? The union means or, so you just start with your starting symbol goes to one or the other. Yeah. Yeah, sure. So that was a particular example, which we haven't done the whole example yet, but this is the strategy to get the union. You make your two separate grammars and you put them together with the or sign, the bar. All right. Let's see, can we do this particular example here? Well, the S1 is really the same old thing. So in this case, S1 goes to A, S1B, or epsilon, right? That's how you get balanced A's and B's. Same number of A's and B's. And then X such that X has an even number of A's. Anyone have a suggestion how we could find a grammar for that?
Do A squared S2. S2 goes to A squared S2, so it's like always.
Uh-huh. That's a good idea. That's the same as like what I said in the previous example, a to the 2n. This, maybe I wasn't clear enough. I mean, x is, it has a's and b's in it, but the number of a's is even, which is quite a bit more complicated than that. Anyone have a suggestion? You don't have to tell me the answer all at once, but anyone remember, like, how would you do something like this? With a grammar? We actually did do an example like this last time. I don't think that will work exactly. If you have, you don't want, for instance, you don't want to allow S goes to A, because that's an odd, like A by itself would be an odd number. You have to make it an even number. And remember strategy for this? I will point out that second set there, X has an even number of A's, that is a regular language. Remember, this is like similar to examples we've done of regular languages before. Evens versus odds, typically you can do that with a regular language. So how do we make a grammar for a regular language? If you, I mean, you can try to just make it by hand, but if all else fails, you can make an NFA and then translate that into a grammar. That's always going to be possible. Sometimes there's simpler tricks to get around that, but I don't think so in this case. So I'm going to make an NFA for this. Even number of A's means like this, right? Where this is accepting. And then it can do any number of B's. That's an NFA for the second language there, second set. And then we can translate this into a grammar. If I call the first one S, I'll call it S2, just because I know that's eventually we're going to call it S2, and I'll call the other one T. Then this says S2 goes to, I hope you remember how to do this, BS2 or AT or epsilon. The BS2 refers to this looped edge, the AT refers to this A going across, and the or epsilon refers to the fact that this is an accepting state. It's something we did a couple times ago. And then T goes to BT or AS2. So that's my second grammar. And my final answer will involve combining these two things together. All right. So for this example, L has a context-free grammar as follows. S goes to S1 or S2, and then S1 goes to A, S1B, or epsilon. S2 is that more complicated thing. B, S2, or AT, or epsilon. And then T goes to BT, or AS2. I think that's my final answer. All right. Sorry, I'm scrolling like a madman here. Sometimes going up, sometimes going to the side. I'll try to keep my scrolls in the vertical direction from now on. All right. Excellent. So these are simple tricks, the concatenation and the union. All right. So when I describe to you a complicated language, it is often helpful to break it up either as concatenation somehow or as a union somehow. Let's try. I got 2 examples, and then I have a bunch for you all to try. See if we can do them. These are similar to, what you might expect for the homework. So here's one. Make a context-free grammar, CFG, for this here. How about A to the N, B to the M, where N is greater than M. So A to the N followed by B to the M, where we have more A's than B's. All right. Now we actually did this example a couple times ago, just sort of thinking from scratch. But I want to demonstrate how sometimes thinking of this as a concatenation can help. How can we think of this as a concatenation? Now, you cannot, the most obvious way to break this apart into 2 pieces would be the A piece followed by the B piece. But actually, this is a bad idea in this example because in this set, there is some relationship between the N and the M. And so you can't just totally separate those things out. Then you'll lose the N and the M are somehow linked together. Like they're not equal, but they have a relationship between them. You cannot separate them like that. Instead, that's a natural idea, but it's not going to work. Instead, I'm going to, this is slightly tricky, I guess. I'm going to write it this way. You have to rethink your original set, but this time K and M can be anything. So what this says is, see, in my original set, there's like extra A's, right? And as a concatenation, I'm going to write it to explicitly look like that. It looks like the same number of A's and B's, but then there's extra A's on the front. And now this can be separated apart because the K has nothing to do with the M. Each of the K and the M, they can be whatever they want. Right? So my concatenation, we kind of split apart this and this. And actually is that exactly the same as what I started with? The very first thing that I said when we started today was almost identical to that, right? Your grammar this time will be, first of all, it's a concatenation, so I'm going to go like that. S goes to S1 followed by S2. And then S1 is just A to the K, so that's A, S1, or epsilon. And then S2 is the balanced A's and B's, which is ASB, or epsilon. Whoa. Whoa. Like that. AS2B, yeah, thank you. You don't want to go all the way back to S. That'll mess it up. Although, I think in this particular example it wouldn't matter because we would just get extra A's, which is already part of the language. But generally, that would screw it up. All right? Yeah. Yeah. No, I think the young man is right. K should not be 0 in this case. If K is 0, then it doesn't actually fit the format of this set. So, yeah, thank you for that. K is not 0. How do I make that happen in my grammar? There's a simple way to ensure that we get at least 1 A on the beginning, not 0 A's. Yeah. Yeah, change the epsilon right here. It's not working. Right there to an A. So right here, it used to say AS1 or epsilon, meaning you make a bunch of A's and then you finish off by epsilon. This says you make a bunch of A's and you finish with an A. This prevents you from taking 0 A's. You have to take at least 1 A. Excellent. Thank you for that. All right. One more example. How about, here's one in which you have to do sort of a non-obvious union. A to the n, b to the m, where n is not equal to m. You might be tempted to try and make this a concatenation, but you can't really. I mean, the previous example, we could make that a concatenation because we knew there were extra a's. And so you can split out the extra a's, and then there's some same number, right? But here, there could be extra a's, but there could also be extra b's. And so you don't know which way you can split it out, right? Anybody feel like that has anything to do with a union? You may have noticed, I did just use the word or. Yeah? Yeah, so this is not obvious when you're just looking at this, but if you think about it a little bit, you might decide it would be useful to break this up into two cases, where the n is bigger than the m, or when the m is bigger than the n, and that's a union. So I'm going to write this as a union, a to the n, b to the m, such that n is bigger than m, in which case we just do exactly what we did in the previous example, or a to the n, b to the m, where m is bigger than n. In which case it looks more or less the same as what we did before, but not exactly the same, right? So we have a union, and each of the two parts of the unions looks like the one that we did in the previous example. Would you mind if I'm going to, just to make this a little easier, I'm going to rewrite the answer in the previous one without using any S1s and S2s. How about I'll call this T and R. T goes to AT or A. R goes to A, R, B, or epsilon. I'm doing that so that I can just reuse the same thing with ones and twos, because basically the answer for this example that we're doing now is the same, but has kind of two parallel versions of the same thing. So my answer for this one is going to be S goes to S1 or S2, the bar. And then S1 is just the same answer as we got in the previous problem. So S1, I'm going to say goes to, I'll write it as T1, R1. T1 goes to A, T1, or A. R1 goes to A, R1, B, or epsilon. So I pasted in the answer from the previous problem for S1. And then the S2 is going to, again, look like the answer from the previous problem, although I suppose not exactly the same. Would you mind if I write it over here just so I don't have to scroll away? I'll go T2, R2. What's the difference? Yeah. Swap the B's and the A's. So for T2, it should this time, actually, sorry, I've already messed it up, I think. This one we are thinking of as A to the N, B to the N, followed by extra B's, right? So the two parts are like that. So the T's and the R's, actually, they play opposite roles. The T is the balanced one in the second one, right? So the T goes A, T2, B, or epsilon. And the R is the one which generates the B's. So the R2 looks like the T1, but it has B's instead of A's. So it's BR2 or B. Right? That's a little tricky, perhaps. Any questions about that one? That's how we do it. Great. I got some for you to try. We got 15 minutes. Probably not enough time to do all of these, but we'll take a look anyway. All right. This one's pretty simple based on If you followed the other ones. Do we even need to do that? That's very much like some of the other ones that we did already. If that's too simple, you can skip the first one. So of these, actually only the first two are ones which are helpful to think of in terms of unions and concatenations. The other ones are just kind of anything goes. See what you can come up with. Feel free to talk to your friends. If your friends aren't at home sitting in the backyard, can't talk to them. What? She's gone. Because I wasn't making fun of her. I was envious. She couldn't handle it. All right. I didn't notice. Called her out. So in your class, is a lot like this one? Did you do the pumping llama?
No.
Yeah.
I'm not sure. I'll ask for that. I had it really right before this class. That's why it's like, but it's so repetitive.
People who are double majors have to take both.
Yeah, I have to take both. So I was like, I'm taking both. It actually works out that I'm taking both in the same semester, but it's like reinforces everything.
But yeah, our math majors, there's only two. Yeah, only two. Hard to.
I think it's good to have both for the different majors, but when you have the double majors, maybe it is an exception, but I don't know.
How far is it? I write my not all my things like this. Even that's an A and 9 and a D. Oh, no. Okay. All right. No. That's supposed to say X has the same number. The same. Maybe I left out the word the, so it. The same number.
Is this one of the ones where you should run an NFL test for the same number?
That's not regular. Yeah. See. That one's a little tricky.
So I was thinking you could do like AB or BA, but then you also have AAB on an AAB.
Yeah. So AB, AB, AB.
Yeah.
Yeah. Any thoughts about same number? My suggestion would be, so you want to make sure there's the same number of should. So always create every day the same number. So that kind of like now you won't do it with all the days but yes. Oh, that's a good idea. You can't quite get anything you want. Because, for instance, if you want to put AA at the beginning, you want to also put BB at the end. Which you don't want that kind of restriction. Yeah. All right, let's talk about these because we gotta go soon. So the first few are pretty straightforward based on what we've already done. This one, you should do something like S1, S2, S1 goes to A, S1B, or epsilon. S2 goes to A, S2, or epsilon. All right? I hope everybody got something like that. Any thoughts about that one? Great. Okay, the next one is similar. It has a bunch of B's at the beginning. I'll do this one over here. But then it has A's balanced with 3 B's each. So you want something like S1 followed by S2. S1 goes to B, S1, or epsilon, and then S2 goes to A, S2, B, 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 if you like, or you could write B cubes. All right, I think pretty much everybody wrote something like that for that second one. Any questions about that one? Okay, those are the ones which involve concatenations or unions. They do not involve unions, but the next one is more of a standard balancing. You want to balance, each B has to match up with an AD. So the way to do this one is just ADSB, or epsilon, right? You create AD at the same time as a B, and that's how we do that one. Any thoughts about that? Okay, the last two are the tricky ones. Same number of A's and B's. Anybody want to give me a... I saw some lively discussion happening concerning this one. Anybody have a suggestion? So, can I just start? Here's something to start off with. Everybody at some point thought of this as the answer. If you think a little bit more, you'll realize this is not the answer, because this one forces all the A's to be at the beginning and all the B's to be at the end, which is not really what you want. You want to allow them to be mixed up. So, here's a variation that I saw. How about that? Or epsilon. Now it could go either way, right? You could have the A's at the beginning, B's at the end, or B's at the beginning, the A's at the end. This, I believe, is still not correct, though. Anybody, can anybody do better about this? Or maybe anybody agree that this is not correct? You got a better suggestion? Okay. Uh-huh. Okay. I think that's the same as what I wrote. I think because, no, it's not the same. I'm trying to think if this is correct or not. I'm not sure. Like, for example, can you get A, B, A, B? Yes, you can from this. Can you get A, B, 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 A? Yeah, I think you can. It can be difficult to tell if an answer is correct or not. Can I make that string using this grammar?
Yeah.
I'm not sure. I don't know. This is a very good answer. I'm not convinced that this is a correct answer. Did anybody have another attempt that you think is correct? Yeah. Yeah, I think this is what I had in mind, and it's a little clearer to me that this really does work. Basically, the idea is I'm just trying to list out all possible ways to generate A's and B's together. The important thing to ensure that you get the same number of A's and B's, you need to make sure that every time you make an A, you also make a B. But you don't want to require that the A is always before the B, or the B is always before the A, or anything else. So you just list out what we're trying to do here is just make a list of all the possible ways that you can make A's and B's together at the same time. And I think this satisfies. Although if you're not convinced that this is all possible ways, you might as well, just to be sure, I might as well put these in there too, right? Now I think I'm totally convinced that these are all possible ways that you could ever create B's and A's at the same time, all right? Probably you don't need those last two, but it doesn't hurt to put them in there, all right? Excellent. And then the last one, maybe the last one is easier than these previous ones. X followed by the reverse of X. I think I saw some good answers for that one. Did anybody feel like you got that one? This one is a little easier because, for example, in this string, if it begins with A, you know that it also ends with an A, right? And if it begins with B, it also ends with a B. So here I would say something like S goes to ASA or BSB. Now this, what I'm about to write is not quite true. No, this is true. That's the right answer. Any string like this must have A at the beginning. If it has A at the beginning, it also has A at the end. If it has B at the beginning, it also has B at the end. And any string like that can be built up by doing these properties over and over again. All right, I think that'll do it then. Have a great weekend. We will have homework due on Wednesday as usual. See you next time. Yep, see you.